Hi, grade 12 student. Our study today is about extreme values. Extreme values is of two types. Extreme value, it means where we have a maximum or minimum. We're talking about max and min. So here we have two types, the endpoints. Sometimes, not always, we have starting point like here at point A, and we have an endpoint at point, for example, here at B. And we have what's called the critical point. What is a critical point? Critical point is any maximum like here or any minimum inside the boundaries, not at the endpoints, inside the boundaries. And it's of two types. Either the derivative equal to zero, it's a vertex like at the point C and the point E, or it is an angular point where derivative, the point exists continuous, but the derivative does not exist undefined. So here, if we take this graph, as you can see, I have a maximum, minimum, as we said, and endpoints. In this graph, always we have two kinds of extremum, two kinds of maximum and minimum. The highest point, if it exists, it's called absolute maximum, like that point here, it's called absolute. And the least point on the graph, which is here at the end point A, it's called absolute minimum. And any maximum or minimum, it's called at the end local because it's neither highest nor lowest. So if I take this graph here, if I want to do this graph, I have xy, what kind type of extreme values here? EV, you can type of extreme values that we have, EV, and what kind of extreme. As we are going to start by the endpoints. We have at the point A, we have an endpoint. This is starting point and going up. So this is the least point that I have. So it has an elevation, suppose f of a, which is unknown and now. It's an endpoint, but it is an absolute minimum. I have at point B, which is an endpoint. Its elevation is f of b. It's an endpoint. Type of extreme values is an endpoint. It is also a local minimum. It's a local because it's not the highest point on the curve. However, if I go to the critical point, the critical points are the points max or min inside the boundaries. So you have here at point C, it is a maximum where derivative, it's a critical point where derivative equal to zero because it is not a cusp, it is a vertex. And that vertex here, it's a local maximum. It's not absolute because this point is bigger, higher. You have at point here E, it's also a critical point because it's inside the boundary. It's a vertex, so derivative here at this point C is equal to zero. And it is, sorry, here, and it is at the point E, it is also, this is E, this is C. It is also a local min because it's a minimum. It is not absolute because this point is less than this one. So that's why this is absolute here, this is local. And here at the point D, it is the highest point. This is called absolute max. It's a critical point because it's inside the boundary, but f prime of x is undefined because it's an angular point. Let us take another example with numerical value. Suppose here we have this graph. We're going to study the extreme value. We're going to denote its type, and we're going to state if it's local or absolute, max or min. Let me start by the endpoint. You have at -3, the elevation of this point is -1. It is an endpoint. It's not the least point. It's a point where we're going to start. This is called a local min. You have another, the endpoint, which is another one. It's at x equal to 3. Its elevation is a 3. The curve is going to that point. It's a local min. Okay, so it's not an absolute because the minimum I have this point is the absolute, and that point here is the absolute max. So I go now to the critical point. I set critical point all maximum or minimum inside the boundaries. So I'm going to start at x equal -2. The elevation is 4. This is called the critical point. It's vertex. So it's f prime of this here is 0. The tangent is horizontal. And it is a local max. Local max because it's not the highest point. This is the highest point here. This point here at -1 here, it's a critical point. It's vertex. F prime of -1 is 0. This is also a local min. Now, it is not absolute because this point is the absolute minimum. You have here at the point minus 0.5, its elevation approximately 2.5. Also, it is a critical point. Derivative equal to 0, its local maximum. Here at the point 1, the elevation is minus 2. This is the least point here. This is called absolute min, sorry. But here it's an angular point, it's a cusp. So it's a critical point, but a frame of 1 is undefined, but certainly it's continuous. And at the point 2, you have 5. 5, if you can see here of graphically or comparing here, it is the highest point. So since the highest point, it's called absolute max, and there it's a vertex and derivative equal to 0. I want you now to fill this table. You have boundaries from minus 4, which is an endpoint. You have 5 endpoint. Here you're going to say these are the endpoints, which one if local max, local min, and you have here the critical point. I want you to solve this problem. In a while, we're going to go, after you solve this problem, we're going to go to the second part. The second part, the graph is not given. You have a function like here, where we're going to study and we're going to find the extreme values, the endpoints, the local max, local min. You're going to graph it. So I'm going to see you in a while in the second video.